Hello, this is to show you how to solve the problem of the diet problem of two variables using the Excel solver. We have to develop a special diet of two foods, P and Q, containing each packet of them of 30 grams contains 12 units package. The first package contains 12 units of calcium, 4 units of iron, and 6 units of cholesterol, and 6 units of vitamin E. Each packet of the same quantity of food Q contains 3 units of calcium, 20 units of iron, 4 units of cholesterol, and 3 units of vitamin E. The diet requires at least 240 units of calcium and at least 460 units of iron and at most 300 units of cholesterol. How many packets of each food should be used to minimize the amount of vitamin A in the diet? What is the minimum amount of vitamin E? We have to answer two questions. What are the optimal values of P and Q? We will call them X and Y. And what is the objective function value of vitamin A? If you go to the other slide here, you will convert the story we saw in the previous style and put it in a table form. We will take this table form to formulate the linear programming model. Now we go to Excel, and in Excel we have three important sections. First, we define the variables. The variables, as we mentioned before, will be X and Y. And these variables has values. The values should appear here. Linear programming does not require a starting value, but because we like to read the numbers, I will put one here and one here as a starting value. But if you don't anything, nothing will happen. Then we will do the objective function. The objective function in our case will have coefficients from the previous table, which will be 6 here of vitamin A and 3 here. To calculate the objective function, we will call it capital Z. I have to multiply 1 by 6 and 1 by 3. To do that, I use the sum product formula in Excel, defining this row here, comma, and this row, and then close. Now we get the number 9. The next section will be constraints. The constraints have 3 constraints of the type greater than or less than or equal. We will put the calorie here, the calcium here, we put the iron here, and we put the cholesterol here. The coefficients, according to the previous table, we will have 12 here, 3 here, and we will calculate the right hand side of the equation and the type of the constraint. For this particular thing, the type of constraint is greater than or equal. Therefore, I will add here greater than or equal. And then the left hand side will be 240 according to the previous table. For iron, it will be 4 here and 20 here, and the left hand side is 460. For cholesterol, the coefficients are 6 and 4, and the left hand side or the right hand side will be 300. Actually, you should change this, and this will be greater than or equal, but the third one is less than or equal. I will insert here symbol, and then I will use less than or equal. Therefore, according to the equation side, this will be the left hand side, and this is the right hand side. No problem, we will switch them like this, just for, yeah. How to calculate this? We have to multiply 1 by 12 and 1 by 3 to get the left hand side calculation. I will write here sum product again, and then use this. But because this will be copied down, I have to use absolute reference. I have to push F4, then comma, then use this two, and then close the bracket. Push this down like this. Now we have the model. We have variables. We have a section for objective function and a section for constraints, and we want to calculate the optimal values and calculate the value of vitamin A at the solution. I go to data and then go to solver, and then click at the objective function and say we like to minimize vitamin A by changing these two variables and adding two types of constraints. Two of these will be greater than or equal these two. I will add to this that this constraint is less than or equal this value here, and then I will say OK. Then I will go and choose the type of optimization. I use simplex linear programming. I use solve. The problem found the solution, and it was integer solution, and this is the solution we obtained. Therefore, the optimal solution is 150 of vitamin A, and the packages from P and Q, or X and Y, are 15 and 20, and this is the same solution you found if you go to the graphics. This is the equations after being reduced, and then the equation, the solution is here, 15 and 20 as we obtained. I hope this clarifies the way to use the Excel solver to solve a small problem of the diet. Enjoy, and I'm waiting for your response.